presentations today. This first one was really intended to be an overview of de-identification and de-identification methods. I was really planning to cover key concepts around secondary uses of data, data sharing, position de-identification in the context of data sharing and data reuse ecosystem. The plan was really to cover a series of issues, so I'll put on the screen a number of issues that we've experienced and that are important to address when you're using and sharing data for secondary purposes, and then I'll talk about them and discuss how we've dealt with them, how other jurisdictions have dealt with them, and so on. I've been doing this for 15 years. And as mentioned in the introduction, I run a software company called Privacy Analytics. I've been doing that for 12 years, focusing on data sharing, data de-identification. So we've been solving this problem globally for many years. So I'll try to bring in some of those experiences as well and some of the issues we've faced over the years as part of this, this presentation. And even though the experiences are global, the same issues come up in many different places. So many places have similar challenges and run into the same set of issues over time. This one here? Next one? Oh, well, doesn't matter. Okay. And then just to also contextualize this, most of my experience has been with health data, but not exclusively with health data. So I'll bring in some other perspectives as well along the way. So the first thing I want to make a distinction about is primary and secondary purposes for processing data. This is an important distinction to make. So in a typical healthcare context, a primary purpose would be providing care to patients, and a secondary purpose would be, for example, public health and research. These are typically considered to be secondary purposes. But the distinction between a primary purpose and a secondary purpose does vary by jurisdiction. So, for example, in the US, treatment, payment, and operations are considered primary purposes. So, for example, any uses of data for the purposes of billing are considered a primary purpose, whereas in other jurisdictions, such as the UK, the distinction is between direct and indirect care, and therefore billing is treated differently. For us, we're really focusing here on secondary uses and disclosures of data, de-identified when you're using or sharing data for secondary purposes, you need to have a legal basis for doing so, and I'll talk about those in a minute. But the role of de-identification is that it allows you to use and disclose data for secondary purposes without having to go and obtain consent. So de-identified data is not considered to be personal information, and therefore, in principle, the obligations around the handling of personal information do not apply anymore. But I'll talk a little bit more about that because there are, I think, important nuances. Okay. So just to clarify, our focus here is really on secondary purposes, and I will not talk about primary purposes, but it's really important to understand where the line is, because sometimes I see there's confusion about what is a primary purpose, which is typically consented, either implied consent, typically through implied consent. It's important to understand what's a primary and what's a secondary purpose in order to know what the legal basis is for using that data. So let's talk a little bit about consent. So if you want to use data for secondary purpose, one option is to go and obtain consent of the patients. I will not talk about how to obtain consent and the different definitions of what's an acceptable consent. There are differences, again, among jurisdictions. In some jurisdictions, you can obtain a broad consent. where in others it has to be very specific, and every time you use the data for a different purpose, you have to go back and obtain consent again. So what's considered an acceptable consent will vary. And then, of course, there are discussions around dynamic consent. So consent doesn't have to be static. It can be ongoing as data is used for multiple purposes. So there are different ways to obtain consent, different technologies. But that's, for now, I think I'll leave it at saying that there are consent is one of the legal bases that you can use for processing data for secondary purposes. So if you want to do data analysis on the data, if you want to, you have big data projects, you have an AI initiative, you can always go back and obtain consent. Obtaining consent, of course, is not always practical. There's a lot of evidence that there's consent bias. We did a study some years ago. We wanted to do a systematic review of consent bias, and we ended up doing a systematic review of systematic reviews because the evidence was quite significant demonstrating consent bias. So it doesn't mean you shouldn't do it. It just means you have to be cognizant that there may be systematic biases between consenters and non-consenters. And there's also, of course, the issue of practicality. Sometimes it's not practical to go back and obtain consent many years later for a large number of people if you're trying to reuse an existing database. But if you can, consent is certainly one way to be able to process data for a secondary purpose. There are also some exceptions where you can use and disclose data for secondary purposes without consent and personal data, that is. For example, and some of these exceptions are mandated and some of them are discretionary. So for example, reporting communicable diseases would be a mandated requirement, or is a mandated requirement in many jurisdictions where you report identifiable information. Public health surveillance is a discretionary. Again, in many jurisdictions, it's discretionary where you can disclose personal health information as a provider, for example, at your discretion for public health purposes. And then you have research as well, which is another exception. You are able to disclose personal health information for research purposes as long as the Research Ethics Board approves the study. So the Research Ethics Board can waive any conditions on getting access to personal health information for research purposes. In practice, many research ethics boards are reluctant to do that, but they can, in principle, allow the researchers to get access to personal health information for research purposes. So we will. So these are available. If they apply, then they can be used to get access to personal health information for secondary purposes. If you are in a research context and get REB approvals, or if you're in public health, or one of the other exceptions applies to you. And then the other way to get access to health information for secondary purposes is by de-identifying that data. So that's really what I will be focusing on, is de-identification. And the idea behind de-identification is once data is de-identified, it's no longer personal information, and therefore the obligations under the privacy statutes don't apply anymore. Although, again, I'll talk a little bit more about that. It's a little bit more nuanced in practice, but in theory, that's the case. For de-identification, there's a large body of work. There's 40 or 50 years of literature on how to de-identify data. There's a large literature in statistical disclosure control that has evolved over many decades. So this is not a new topic. It's been around for many years. And there are a lot of methodologies and techniques that have been developed for de-identification, and I will talk a little bit about those at a later stage. And of course, in the context of health data and sharing health data, there's a lot of expertise and experience as well in de-identifying health information. So I will talk a little bit about de-identification and just some of the basic principles and issues around de-identification. One key thing to keep in mind is that terminology in the world of de-identification is not very consistent. Different jurisdictions and different disciplines use terminology in different ways. So if you see folks referring to the same concepts using different terms, don't be surprised, or use the same terms to mean different things, don't be surprised. That's one of the challenges in this area, just because de-identification has evolved in different disciplines and also has evolved in different jurisdictions. The main history is national statistical agencies were collecting census data and doing large surveys, and they were required to share that data, so they developed these de-identification techniques for that purpose, and different statistical agencies in different countries developed different ways of describing the work that they were doing. So don't be surprised by variations in terminology. So I'll use the terms de-identification and anonymization, which is another term that's commonly used interchangeably, just because it's easier in some cases to change things around a little bit. So a key concept then with de-identification is that identifiability of individuals in a data set falls on a spectrum. So you have one end of a spectrum where you have identified individuals that are easy to know who they are, and the other end of the spectrum you have de-identified individuals where it's impossible to know who they are. So for example, a database with identified individuals will have, for example, their names and addresses and telephone numbers, so it's obvious who they are. And so this part of the spectrum of identifiability has identified data. As you go further down this spectrum of identifiability, you start removing some information from the data. For example, you'll delete the names, you'll remove the health card numbers, your social security numbers, or social insurance numbers, and as you remove these direct identifiers, you end up with pseudonymous data. So pseudonymous data has less identifiability because you removed information, you removed the obvious direct identifiers, but it's still considered personal information. And this is consistent around the world in all statutes, and that pseudonymous information is still personal information. So if you have any data, health data set, and you remove the names and addresses and telephone numbers and all the direct identifiers, that's good for protecting the identity of the individuals, but it's still considered personal information. And the reason is because it's still easy to identify individuals from other information in your data. So for example, in Canada, the vast majority of the population is unique on their date of birth and postal code. There have been a number of studies that were done on this. We did a study in Quebec, and the government of Alberta did a study on their data, and about 99.6% of the adult population is unique on their date of birth and postal code, for example. So other pieces of information in the data, demographics, socioeconomic status, and so on, can still make individuals unique and can still be used to identify them in data. So pseudonymous data is less identifiable because you've removed some information, which is good. And then if you move down the spectrum a little bit more, you have this concept of strongly pseudonymous data. So with strongly pseudonymous data, you apply more transformations, you make sure that nobody is unique in the data. You may have some controls that you put in place, security controls, privacy controls, to manage the data. But because it's still pseudonymous data, it's still considered personal information. So you have different levels of pseudonymization, but all types of pseudonymous data are still considered personal information. And this is really important because I often see organizations who will pseudonymize the data and say, well, there are no names left, it's no longer personal information, we can do whatever we want with it. That's not necessarily the case. Pseudonymous data is still considered personal information and still has to be treated as personal information. And so, if you want to use it for secondary purposes, etc., you still need a legal basis to process it for that secondary purpose. Pseudonymization is necessary, but it's not enough. And then there is this concept of a threshold. So somewhere along the spectrum, there's a threshold which distinguishes between personal and non-personal information. And once you cross this threshold, then you move it to anonymous data or anonymous information or de-identified information, and then everything after this threshold is considered non-personal information. And then if it's non-personal information, you can, again, in principle, use it and disclose it for secondary purposes without having to go back and obtain additional consent. I'll talk a little bit more about this, where this threshold is and how you define that threshold, but there are well-established precedents for defining what an acceptable threshold is for anonymization or de-identification. So this is always one of the first questions, and then when we go through the evidence, it's one of the least controversial issues at the end of the day, because there's so many precedents for what's an acceptable threshold for de-identification. Canadian precedents, American precedents, European precedents, Australian, New Zealand, across the world, many organizations copy each other. So actually there's a well-defined range of thresholds that have been used in practice to de-identify data. And once you've applied the de-identification, you've transformed your data in this way so that your identifiability is below the threshold, then it's considered anonymous data. So then another key concept here is that you're able to measure identifiability. So this identifiability is a probability. You have a probability of value between 0 and 1. And when your probability is below a certain threshold, then that's considered to be de-identified data. So this means that there's no such thing as zero probability. There's always some non-zero probability that the data is identifiable. Even when it's anonymous, even when you've crossed the threshold, it's still not zero. There's always going to be some non-zero probability of the data being identifiable or of individuals being identified in the data. And that's just how it works. If you want zero risk, then you shouldn't be sharing data, because there's no way you're going to be able to share data and achieve zero risk. If I have a data set and I randomly assign names to people in the data, I may get some correct by chance. So you just can't guarantee zero risk. Therefore, the objective really is to determine what's an acceptable risk, which is the threshold, and then ensure that the data, the risk in the data or the probability in the data is below that threshold. So in terms of methodologies for de-identification, these are the four that I generally see. There's risk-based de-identification, which is the methodology that we use and the one that I will talk about more as later on. The rule-based methodologies. So rule-based approaches are essentially fixed rules where you say, for example, as a simple example, I'm going to convert all my dates of birth to 5-year age intervals. So that could be a rule that you apply across the board to all your data all the time. And then there are some methodologies that add noise to data. So every time you get a value from the data, it has some random noise added to it. So it essentially adds some uncertainty to the information in the data. And then I see a lot of homegrown approaches as well. I definitely wouldn't recommend homegrown approaches because some of them are we found are easy to break. But the risk-based, rule-based, and noise approaches, or noise addition as kind of general categories, have some foundations behind them, but they vary in their strengths and weaknesses. For example, rule-based approaches are very simple to apply and understand, but they don't provide strong guarantees. Risk-based approaches provide stronger guarantees. And then noise addition approaches can provide some guarantees as well. Okay, so one key thing that comes up when we de-identify data and share data is ethics. A question that often comes up is whether it's necessary to obtain an ethics review to perform a secondary analysis on de-identified data. So let's say I get a de-identified data set, and I'm from a registry or a government agency. Do I need to get ethics review to do an analysis on that data set? And I mean, in general, in Canada, yes, the answer is yes. That secondary analysis on data that has been de-identified does require an ethics review. And the reason is because the ethics review needs to look at group harms. So you may still do an analysis on a de-identified data set and then draw conclusions about a particular group of people, and these conclusions may be stigmatizing, may result in discrimination against that group, may be very creepy and surprising. So, so this is what the ethics review is intended really to look at. Issues around group harm, and of course an ethics review also, at least in a research context, would look at whether the de-identification method used was appropriate or not. In other jurisdictions that I have seen outside Canada, the an ethics review of a secondary analysis of de-identified data may not be necessary because it's not considered human subjects research. So again, the perspectives differ by jurisdiction. But in a Canadian context, at least for research ethics reviews, you do need to obtain that for de-identified data as well. And as a practical matter, if you want to publish your research, most journals now will require evidence of an ethics review or a letter from an ethics board saying no ethics review is required in order to allow you to publish. So doing an ethics review is generally recommended even if it's performed on de-identified data. And this also applies to commercial research or commercial analysis, not just academic analysis. So in a commercial setting, if you're going to publish your research, you still need to go through an ethics review process, for example. And of course, it's the right thing to do because you also want someone independent to look at potential of group harm by analyzing data, existing databases. Another key thing is providing notice. So it's not required to provide notice, but it's still considered a good practice. So providing notice means you tell the patients that you're going to de-identify their data and you're going to use the data for secondary purposes. And if you can define what these secondary purposes are, even if it's a high level, that's always going to be a good practice. And notice can be posters in the clinic or in the hospital, or it can be information on the website, for example, or both. So we did some work with Born, which is the birth registry in Ontario, and they do both. They give leaflets out to mothers I mean, it's not the best time to be handing out leaflets, but there is a leaflet with information which includes a statement about using data for secondary purposes, and the information is clear on their website. So a strong level, a high level of transparency there, and I think that's a good example. Providing notice is important from the perspective of social license, and I'll talk about that as well a little bit. You know, some organizations will do the absolute minimum just to be compliant and check the box. You know, these exist. Some organizations will see secondary uses and disclosures from a more general perspective, from a risk management perspective, and so they want to make sure that they have greater social license to use the data for secondary purposes, and this is where notice becomes important and can play a role in obtaining that social license. And of course, at the end of the day, given that this is not a requirement per se, but it's a highly recommended good practice, of course, every organization has to make a judgment call on whether they want to do this or not, but my recommendation would be if there's an opportunity to provide notice, then you should do that, even if the plan is to de-identify the data that you have and use it for research or commercial purposes. Okay, so I'll cover also a couple of common questions that come up. They come up globally, actually, in many jurisdictions. So one question is whether you need consent to de-identify data. You know, the general answer is no, but people still debate it. So for example, in Ontario under PHIPAA, it's very clear that de-identification is a permitted use, which means that the data custodian is permitted to de-identify data without having to go back and obtain consent. The act of de-identification does not require consent. In some jurisdictions, it's considered a non-use. It's not even considered a use of data, and therefore it's not necessary to obtain consent. But when the legislation is silent, there's debate. And sometimes when the legislation is not silent, as in Ontario, there's still some debate. So it's really very helpful to be clear about this issue. Obtaining consent for de-identification creates a strong disincentive to de-identify data, which will then make it, the outcome of that will be more personal information being shared, because if you're going to obtain consent to de-identify, then you might as well to obtain consent to use the data and not bother with de-identification, and therefore you'll have less data available because of consent bias and the difficulty of obtaining consent in some situations, but also the data that will be used will be predominantly personal information rather than de-identified information. So it's not a good practice to create strong disincentives for data protection mechanisms. So in general, then, it's better if no consent is required for de-identification. It's the law in some jurisdictions, and it's quite impractical to do otherwise in any case. In the U.S., just as an example, under the HIPAA privacy rule, a covered entity or a provider either needs to do the de-identification themselves, or they have to explicitly give permission to an agent or a business associate to do the de-identification for them. And if the provider or the covered entity doesn't explicitly give permission, then that's considered no permission. So kind of a different perspective or an additional perspective on this is consent for de-identification, and then authority for de-identification by the provider has to be explicit. So what we see, for example, is some hospitals will work with, let's say, for example, their IT provider, and the IT provider has access to the data, and then the hospital gives the provider permission to use de-identified data for some purpose. The hospital has to give, if the IT provider wants to use the data and de-identify it, the hospital has to give the IT provider express permission to de-identify the data. It cannot be assumed that because they have the data and no consent is required to de-identify the data, that they can just take the data and de-identify it. The provider has to provide express permission for the de-identification to happen. Okay. The second major issue, I think, is data ownership. So this is, again, a topic that has come up very frequently, whether patients own their data or not. It's a complex issue. It has been analyzed a number of times from the perspective of copyright law and property ownership law. And the general conclusion in Canada so far is that patients do not own their data, but they have an interest in their data, and they should be given control over their data. But that's a different argument than ownership of data. That doesn't mean that this will not change in the future, but currently that's the situation. And there have been a number of interesting legal analyses of this. It's an issue that's being debated quite vigorously right now. But as of today, that's where we stand. I think the best way to approach this is not to talk about ownership and talk about data stewardship and control and authority to use and disclose data, and not treat it as a data ownership issue.
When you talk about data ownership, is there a distinction here between personal health information and data at this point? Because my understanding, for example, from the McInerney case, was that patients actually do own their personal health information. The physician, for example, owns the record, but they actually own the data. That was my interpretation or understanding of it anyway. So I was just wondering if there's a distinction here between, right now we're just talking about data that's not been analyzed yet. It's not really information. It's just...
Right. So I'm talking about the data itself. So the patients do not own their data. That if there's an ownership right, it probably belongs with the physician rather than the patients.
Okay, I follow.
Yeah. And I mean, Teresa's case has done a really nice analysis recently of that issue. And there are probably nuances there that I'm not conveying, but the general conclusion and that was a legal analysis, so you can approach this from multiple perspectives, but from that analysis, that was the conclusion. And a specific example that was cited was medical information or medical data. So patients have an interest in the data, and they want to have a right to control it, but they don't own it as from an ownership right perspective.
Just to weigh in, I think the way that ownership in this case and how it's been analyzed and applied is really in that IP kind of context, right?
Right.
So in terms of whether individuals have a right, like a right to like have monetary returns on their own information if it's commercialized, like it's really strictly in this context applied in that IP kind of ownership perspective, but maybe larger kind of considerations as well. My understanding, based on what I've seen, is ownership.
It was a copyright. A large part of the analysis from copyright law, for example. I think it's a complex issue, and I've seen people make claims about patient ownership of the data in a very broad manner, and that's not necessarily the case. There are many nuances there. It doesn't mean they don't have rights to the data. It just means that it's not necessarily an ownership right, at least today. And that may change, but as of today, that's where we stand. So from a de-identification perspective, there are different types of data in terms of how they can be de-identified. So, and this applies to structured and unstructured data. So data in tables and so on, and text. So you have clinical data, administrative data, registries, and survey data. So all of these are relatively straightforward to de-identify. There are many methodologies and well-established protocols for de-identifying that type of data. There's also device data, as we're seeing more and more device data. So these could be big devices operating in clinics and hospitals, and implanted devices as well. And so that data can be de-identified reasonably well. And then you have image data. Image data now is mostly in DICOM format. So DICOM data has essentially an image and header information. The header information is essentially structured text, so that's easy to de-identify. And then the images themselves, you have different types of images. Some images have text burnt into the image, into the pixels. So there are techniques to detect text in the images and blur those parts of the image. Sometimes you have facial images, so there are techniques to deface facial images. So I would say that the de-identification of image data is matured. There are good techniques available that can be applied in a reasonably reliable way. And it's getting better over time. For genomic data, and here I'm talking about sequence data, not biomarkers, you cannot de-identify that type of data. It only takes a small number of SNPs to make an individual unique, and therefore although the mechanism to identify individuals from a sequence is complicated and requires expertise, I think the general consensus is that it's getting easier over time, and therefore this type of data is considered to be identifiable. So the manner in which genomic data has been shared today has been to use security controls and privacy controls and provide restricted access to this data rather than attempt to de-identify it. Any approaches to de-identify genomic data reduce the utility of the data significantly, that you can't really do anything with it. So you don't de-identify the data. In practice, people provide access controls, contracts and so on as the ways to manage the risk when sharing genomic data. And increasingly now there are secure computation techniques that allow you to do analysis on encrypted genomic data so that you don't have to get access to the raw data, but you can do analysis on the encrypted version of the data and still get the same results. So there are other approaches that are being developed to allow the sharing and secondary uses of genomic data, but they're not de-identification approaches per se, at least not in the traditional way that we view de-identification. But other types of data, I think there are good technologies to de-identify them and provide reasonable protection. So the other thing that typically or often comes up is separation of responsibilities. So here you have a situation where someone who has identifiable data de-identifies the data and then uses that data for secondary purposes. The question is, can identified and de-identified data coexist in the same organization? And people have fallen along the spectrum here. Some folks will say you cannot have identified and identifiable data within the same organization, and therefore you have to separate them. Some organizations create subsidiaries, so you'll have an entity that provides care or collects data and uses that data for a primary purpose, whatever that may be, to provide a service, to provide care, and then they'll create a subsidiary that's focused only on analytics and secondary uses of the data. So the data is de-identified, it's given to the subsidiary, which is a different legal entity, and then that subsidiary does the analysis and does the AI and machine learning and so on, and does the secondary analysis on that data. That's one approach. Another approach is to provide some strong separations within the same organization, for example, by having different teams, by having them physically separated in different floors or different buildings, and of course keeping the data, the identified and de-identified data separate. And then some organizations have the same data in the same database, and they just have different access controls for different people. And then really at the other end of the spectrum, you have some organizations such as academic medical centers where you have the same person at 9 o'clock in the morning takes care of patients, and then at 12 o'clock they are a researcher and they access the same data for research purposes. So where you fall on that spectrum really depends on many factors. Certainly some jurisdictions are very strict about this in terms of separation of concerns, separation between identified and de-identified data. It's really important to keep in mind that the purposes of the processing are different from primary purposes and secondary purposes, and the legal basis is different. And therefore, you have to make sure that this is taken into account when facilitating access to data. The academic medical center example is a complicated one because you have clinician researchers, but it's something to keep in mind. There are active discussions on this issue, and like I said, some jurisdictions have landed in taken position on this, and others are still discussing it, and it's dealt with on a case-by-case basis. But I see this as an emerging issue that will have to be addressed in academia and government, and also in commercial settings. We're seeing it now in commercial settings, for example, pharmaceutical companies that have access to identifiable data collected from, or pseudonymous data that's collected from clinical trials, and then they're creating data warehouses where they do secondary analysis on that data. And so, again, how do they, so you have the same entity with pseudonymous and de-identified data, different purposes. One is consented, one is de-identified and non-consented, and you do secondary analysis on the de-identified data. How do you separate these two programs of work in a defensible way? So I think it's an issue that's applies across the board. So in terms of data sharing mechanisms, so you have the kind of most open is open data, so you publish and forget. You publish data on the internet, you make it available, and anyone can access it and use the data for any purposes. And of course, it would have to be de-identified data. If it's personal information or personal data, it has to be de-identified before it's published. As a practical matter, it's not really possible to publish rich open data anymore. You can still publish open data, but it has to be, in practice be limited data. If you're doing your job well, it has to be in practice limited data, because it's very hard to de-identify rich longitudinal data sets and put them out in the open. Because the level of de-identification will be so extensive that the data will not have much utility left in it. You can still publish limited data with few variables. Longitudinal data is always high risk. So it's going to be very hard. People still do it, and that's always a risk management decision when you do that. But it's just very difficult to be able to say that this is really de-identified data. If it's very rich and longitudinal and you post it online with no restrictions whatsoever. But still, limited data can be useful, and you can do a lot of useful and meaningful analysis with limited data, few variables or subsamples, etc. But there's just something to keep in mind. It's very difficult to create very rich open data. The second level is quasi-public. So this is still public data, but you have terms of use. So people can go and download the data, but they have to agree to certain terms of use before they download the data. And you need a way to verify identity. So if someone has agreed to your terms of use, the terms of use are not really enforceable unless you know who's signed, who agreed to those terms. So you need some way to verify identity in a somewhat reliable manner, and then those folks have agreed to the terms of use. Typically, the terms of use are you have conditions that you will not re-identify individuals, you will not attempt to contact individuals, that you will keep the data in a secure environment, you will not share the data with other people. Whoever wants the data has to download it themselves, so you can track everyone and make sure everyone who accesses the data has signed the terms of use or agreed to the terms of use. And quasi-public data is sometimes used in competitions. If you have an online competition and you have entrants in the competition, then you will create a quasi-public version of the data where the entrants have to register in order to participate in the competition. And of course, they want to participate. They want to give their correct identity, because if they win the competition, they want to get the prize. So you're incentivized to provide correct and accurate identities. Then the next approach is data download. So this is non-public data, and whoever gets access to the data has to sign a data sharing agreement. Data sharing agreement may have audit requirements in it, but you're allowed to download the data and process it or analyze it locally in your own environment. The next level is secure environment. So you're not allowed to download the data. You go and access the data in a secure sandbox. You log into that sandbox or go to that sandbox physically, and then do the analysis within that sandbox. And you can't access the internet, you can't download, you can't or upload the data anywhere. And the Statistics Canada's research data centers are a good example of a secure environment. And of course, you can create virtual versions of those virtual RDCs or equivalent to virtual RDCs, where online secure environments where you put the data and people can log in remotely and access them. And there are advantages to that as well, in that you can exercise much greater control on the data. And that way you don't have to de-identify the data as much. And then of course you have online analytics tools where you don't even access the data, you just use a tool to do online analysis on the data. The one thing I'll say about online analytics tools, you just have to be careful because some of these tools can leak information. So for example, online query tools, it's relatively well known that if you are able to run a certain number of queries on a data set, you can start recovering the raw data by running overlapping queries and creating either hierarchical tables or overlapping tables. So you just have to be careful about online analytics tools. Sometimes it's a risk management exercise, let's put it that way. Sometimes organizations will accept online analytics tools with minimal privacy protection, on the assumption that folks sign an agreement and therefore they can be trusted and they will not try to attack the data, and they'll take some effort to attack the data using an online analytics tool. And other organizations will be more conservative and not allow online analytics tools because of the known risk. But it's just something you need to know. Like, it's always a risk management decision, and it's good to know that online analytics tools can allow the leakage of personal information if the underlying data set has personal information. So in terms of topologies for data, accessing data or sharing data or reusing data, the simplest example is you collect the data, the provider collects the data, de-identifies the data, makes it available for secondary purposes. But in general, I see three topologies. One is you de-identify data at source. So if you're collecting data from multiple locations, you de-identify the data at those locations before you pull all the data and create a data warehouse where you combine all the data sets. Sometimes it's not possible to de-identify at source because the IT infrastructure doesn't exist at source, for example. So another option is to set up a trusted third party where all the data goes to a trusted third party from multiple sources or from a single source, and that trusted third party then does the de-identification and then sends it to wherever it needs to go for the secondary analysis. And then another approach is where the first use is de-identification. So as a simple example, some of the smart city initiatives where you're collecting data from sensors, and the sensors are very simple. They're very simple devices that don't have much computing capacity. So you can't really de-identify information at the sensor level, but you can collect all the data in one location from all the sensors, and then the first use of this collected data would be to de-identify it before it's sent on for additional analysis. So these are three general ways to de-identify data, and of course, when you're doing any de-identification, first thing you do is understand the data flows and then understand the authorities around these data flows. And from that, you would then determine where the de-identification would happen, whether it should happen at source, through third party, or first use. Commercializing data. So there's a lot of interest in commercializing data. And commercialization of data can mean many different things. So some organizations commercialize data directly by selling data. Some organizations analyze data and create information products and commercialize the information products. And then some organizations provide just analytics tools that sit on their data and let others do the analysis on their data, but don't provide them direct access to the data. Multiple surveys. So when you commercialize data, you can, whether you're a public sector, academic, or commercial organization, we've seen all of those. The Canadian public generally has a bigger concern about commercial uses of their data compared to academic uses. Government uses don't fare very well either, but certainly there's a distinction between academic and commercial uses. And this is not just in Canada, this exists in other jurisdictions as well. So I'm not going to preach on this topic here. I'll just say that there are a lot of commercial uses that are very beneficial. If you've ever taken any medication, you have gotten a benefit from commercial uses of data. So I think there's a really big gap in understanding about how data is used and the benefits of sharing data for different purposes. And I think there's a real need for a more informed narrative around the commercialization of data. There are some tremendous benefits, economic benefits and societal benefits that can accrue from being able to commercialize data. Data is dirty. It requires a lot of effort and resources and skills to clean and use and analyze. This doesn't come for free. So being able to fund and finance the secondary analysis of data to gain all the potential benefits from that data will require some form of commercialization at the end of the day. It's complex, it's hard, and when you start linking multiple data sets together to better understand the patient journey, the complexity increases dramatically. And this will require expertise from a lot of people, and someone has to fund this. But it can be done in a responsible way. Commercialization is not a dirty word. Data sharing can be done in a responsible way and a transparent way, and this is really what we should be striving to achieve, is set some standards and expectations about how to do this well so that we can gain the benefits and manage the risks. And again, there are many views on this issue. There are communities who oppose commercialization of data completely, and there are communities who are for it. So I think it's a discussion that needs to happen. It's an important discussion. Another key thing is social license around secondary uses and disclosures of data. I've talked about this a little bit when I talked about transparency and giving notice and commercializing data and so on. But in general, getting social license is important for the secondary uses of data to be sustainable, which means an engagement with the public to understand the concerns, to educate, and to create awareness about how data is being used and emphasize the benefits of secondary uses of data as well. A lot of the discussions were around the dangers and risks, but there are also a lot of benefits which should be part of the discourse. Another topic that comes up quite frequently is data linking. As more data is available, then there's a stronger desire to link these data sets. And it's not just health data. We're seeing more types of data being linked: health, education, immigration, correctional services, and social services. And of course, the more data, and different types of health data as well. So the more data you're able to link, of course, the better understanding one would have of a patient's journey or social determinants of health. And the data becomes more powerful. There are two ways to do linking. The traditional way is you get identifiable data, and then you do probabilistic linkage on the original data set. If you have things like health card number or health insurance number, these unique identifiers have a very high match rate. If you don't have that, then there are good algorithms for matching on names and dates of birth and place of birth or residence location, etc. And I mean, it is possible to get residence location history so that you can have multiple ways to match data. So that's relatively straightforward. If you match original data, you can link do the linking, and then you can de-identify the linked data and then share the de-identified linked data. It's relatively straightforward. So then the data that's being used or shared is de-identified. The key thing to keep in mind, of course, is that if you have two data sets that are de-identified, data set A and data set B, and you link A and B, the linked data set is not necessarily low risk. So as you add more data sets together, even if the original data sets are de-identified, the combined data sets may have a higher risk of re-identification, and that risk may keep increasing until it crosses over the threshold and becomes personal information or identifiable information. So as more data is combined, the risks go up, and it's an empirical question whether the risks go up over the threshold or not as you combine more information about the patients. But that's something to be aware of. So then there are methods for secure linking of de-identified data. So you de-identify the data, and they can securely link the data sets. So you don't need the names or dates of birth or social security numbers or health card numbers or anything like that in order to link them. So there's secure linking protocols on de-identified data. But then once these data are linked, you still have the issue of whether the linked data sets have a higher risk of re-identification or not. And then the other question, of course, is who should be doing this linking? Because the entity that's doing the linking may end up with data that has a higher risk of re-identification post-linking. So then do they have authority to hold personal information? They were receiving de-identified information, but post-linking, the risk has gone up, and now it's no longer de-identified information. The linked data is a higher risk. It's crossed the threshold. So does that entity have authority to hold personal information at that point in time? There are no easy answers to this. It has to be analyzed on a case-by-case basis to determine what the best approach is. But linking and secure linking does introduce some interesting questions that need to be addressed. So let me talk about complexity. I mentioned this before. Health data is often messy. It's often not standardized, and of course you need to prepare and clean data in order to analyze it. You also need to prepare and clean data in order to de-identify it. So de-identification has some complexity just because it's dealing with data. The same kind of complexity you would face when you're analyzing data, when you're building machine learning models, you're building statistical models, and so on. You are dealing with data, and so you have to deal with the messiness of data. And that's kind of a universal issue. From a de-identification perspective, the level of complexity is largely proportional to the level of standardization of the data. So if the data is standardized, standardized from a data model perspective, from a coding scheme perspective, from a variable naming perspective, then it becomes easier to increase the level of automation to de-identify the data, to the point where you can potentially do complete de-identification with minimal human intervention if you have a standardized data set. So the level of automation varies in practice when you de-identify the data. When you're de-identifying data, and standardization of the data sets is a big factor in determining the level of automation. And of course, the more automated, the more you can scale, and you can identify many more data sets and create larger pools of data that can be used for analysis. So one more thing I want to cover is, of course, data utility. So there's a trade-off between de-identification and data utility. The more you de-identify the data, there's a reduction in data utility. And in practice, it's essentially a cliff. So as you de-identify, the data utility keeps going down, and then at some point, the utility starts to decrease more rapidly. So it's always a trade-off between how much you de-identify the data and how much data utility you have. Of course, you don't want to perturb the data too much, because you still want to be able to perform useful analysis on it. So you want to have, there are very sophisticated algorithms now to de-identify data, to maximize data utility. It's important to choose the approaches and methods appropriately to ensure that your data utility is retained as much as possible in a justifiable and defensible way. I'll talk a little bit about re-identification. So there are different angles to re-identification. Sometimes there's a legitimate need to re-identify data. So a classic example is you take a data set, you de-identify it, you then do secondary analysis on it to identify patients who are eligible for clinical trials. And then once you've identified for a particular trial patients who meet the screening criteria, you would then go and re-identify those individuals and provide that to their physician, who would then contact the patients and suggest to them that there are trials there that they may be eligible for, that may be beneficial for them. So here's an example where you de-identify data, and then you, post-analysis, you would re-identify the data and contact the patients afterwards. So there are ways, and there are legitimate ways to, technically, you can always do this. You can create data sets that can be re-identified. So that's not an issue. You just need to have a key, a pseudonym, and then you protect the key, and then you use the key to re-identify later on. There are ways to manage the technical aspects of this in a very reliable way. That's not a challenge. You have to be careful about implementing re-identification protocols. If you are claiming that a data set is de-identified or has a low risk of re-identification, and there's a backdoor to re-identify it, then you have to be very careful about that and how you're able to justify the existence of that. Under certain jurisdictions, there's an allowance for re-identification under certain conditions. In other jurisdictions, it's not mentioned. There's silence on this issue. And therefore, if there's a business need or a public health need for re-identification in any particular protocol, then you have to work through the authorities that are needed to achieve that objective. I've seen it done, and it has been done successfully in many jurisdictions. You just have to be very careful and think this through if it's a requirement. The other angle of re-identification is actually getting a data set and trying to re-identify the patients, either as a commissioned attack or a malicious attack. So there have been re-identification attacks on data sets and on health data sets, and some of them have been successful. The ones that have been successful were done on data sets that were not de-identified properly. So a lot of these successful re-identification attacks were done on pseudonymous data rather than anonymous or de-identified data. Attacks that were done on de-identified data where the risk was demonstrably below a threshold have been less successful. And there have been a number of commissioned re-identification attacks as well that are used to test de-identification methodologies And so there are known protocols for performing commissioned re-identification attacks on data to evaluate how good the de-identification is. So let me talk about synthetic data. So one other approach that has been suggested is to create synthetic data. So the basic idea behind synthetic data is to take an original data set and then create a synthetic version of that data set that has the same statistical properties. So it'll have the same distributions, it'll have the same correlations among the variables, and therefore the synthetic data then looks as real or very realistic compared to the original data. So as a practical matter, to create a synthetic data set, you need to make assumptions about how the data will be used. So it's very difficult to create a synthetic data set that is useful for any type of analysis. And if you know what kind of analysis will be used, then why don't you just do that analysis yourself, basically. So synthetic data there are use cases where synthetic data is very beneficial and adds value and can solve a real problem. But I don't think synthetic data at this point in time is a replacement for real data. Synthetic data cannot be, you cannot use it to perform an analysis and then say, well, this is the same result I would get as if I had the real data in a general way, right? So, I mean, you can create synthetic data for certain types of analysis. Then if you do those certain types of analysis on the synthetic data, you would get data similar to what you would get with the real data. But a general purpose synthetic data, it's very challenging to do that. But there are use cases, for example, where you can provide synthetic data to allow analysts to learn the data, understand the data, write programs to analyze the data, and then either once they believe that they can do useful analysis with this data, they request the real data set and go through the process of requesting the real data set and signing the data sharing agreements, etc. Or they can write their programs, their R code, for example, and they would submit the R code, and then the data custodian would run the R code on the real data and send them back the results. So there is value from synthetic data. It can solve some real problems, and it can implement workflows that are beneficial, but they're not a substitute for real data. They address a different set of use cases. There's an active community now working on techniques to create synthetic data. Thank you. Are there any questions?